All right, season 1, episode 12. So we're given this model of a rocket being fired up into the sky. We've got, this is the meters in the sky and this is the time in seconds. It wants us to find the maximum height. Maximum is a special word. Have a quick chat about this. If you think back, when we talked about stationary points, there were 3 types of stationary points. Maximum, minimum, horizontal point of inflection. The important thing to remember about all of them is they all occur when the gradient is 0. So this feeds into a whole area called optimization that you'll do more of next year. But for now, the important thing is when you're thinking about minimums, maximums in particular, it's when the gradient is equal to 0. So I'm going to be following that process for this question. So I find the gradient formula. I'll call it dH dt instead of dy dx because there's a h and a t there. Okay, we're just going to lose the t. It's going to be 3000 take 14t. So stationary points are going to be when, dH dt equals 0. So I'm going to set that equation equal to 0. 0 equals 3000 take away 14t. And I'm going to solve it from there. Add 14t to both sides. 14t equals 3000. Divide both sides by 14. T is going to be 30,000 divided by 14. So I put that in my calculator. And I get, well, 1,500 over 7, or approximately 214.29. And we better remember that's in seconds, because we were solving for seconds. Now here, what you don't actually know for sure right now is whether that's a minimum or a maximum. How do you know? Well, there's a couple of ways we can check it. This one I'm going to do quite simply and say, look, the squared component's negative. Remember that if you have a positive x squared or similar, it's always a happy face. It's a minimum. So if you have a positive x squared, it always ends up being a minimum. If I have a negative x squared, you know what it looks like? It's always going to be a maximum. In this case, we had a negative on the squared component. I can be confident that the only turning point's at a maximum. But there are other ways you could check that. You could look at your calculator. You could also use a second derivative. But anyway, that's enough for now. At the moment, we know that the maximum height's going to be at 214.29 seconds. But we were asked for the height. So to find the height, we need to go back to our original formula. We've got this, and we know the time. So we substitute the time into the formula. H is 3000, 1500 over 7, take away 7, 1500 over 7 squared, plus 1. Now, I'm going to put that in my calculator. You can do it by hand. Why don't you do it by hand? All right, open brackets, 1500 over 7, close brackets, take away 7, open brackets, 1500 over 7, all squared, plus 1, and it gives me that, which is a massive fraction, but let's make it a bit more reasonable. All right, so the height is approximately 429.57. Now we're dealing in meters, weren't we? Meters. So it's 321,000 meters off the ground. Put that in a sentence.